If the ordered pair is in the relationship, then B, comma, A is in the inverse relation. And the reverse is true. If BA is in the inverse, then AB. This means you can go forwards or backwards. That's what if and only if means. Okay, I'm going to do some highlighting today. So one of the important attributes is AB goes to BA. Alright, so now let's take a look at how we tell if an inverse or if a function has an inverse that's a function, because it could be a relation and you're like, what's the difference? I don't know. Here we go. I'll tell you what the difference is. Let's sketch a picture of the basic function x squared, the parabola, right? So a parabola, just for some points on our graph, because this is important because we need to flip them around, goes through 0, 0, 1, 1. I know it goes through 2, 4, 2, right? And negative 1, 1. Uh-oh. I'm going to give you a chance to make sure that I don't hear that again. Okay, so then draw your parabola, and this is the equation y equals x squared. Okay. So then, if I wanted to graph the inverse relation of these points, we could reverse the coordinates. So let's try to sketch that graph. If you reverse 0, 0, what would we have? Still 0, 0. How about if you reversed 1, 1? Still 1, 1. Okay. But how about if you reversed negative 1, 1? Then I'd have 1, negative 1. So we have a parabola now that opens to the right. I'm just trying to follow that same pattern, you know, hopefully that makes sense to you. So, does anybody know what the equation is? If this is y equals x squared, remember I just switched the x and the y around. What do you think the equation would be for this? X equals y squared. Very nice. X equals y squared. Very nice. Now, is x squared this one? Is this a function? Yes. Is this a function? No. Why not? Fails the vertical line test. Look at you guys. There's this thing called the horizontal line test. What? The horizontal line test could be used on the original function without having to do this. Okay, so instead of having to draw this and checking, if you would use a horizontal line on here, so I'm going to draw a horizontal line, and what do you notice? It's more than one. All that means is this has an inverse, but the inverse is not a function. Okay, so let's write down the horizontal line test. HLT, I'll call it. And so it is used to check, not the function, it's used to check if its inverse is a function without having to draw it. So the inverse of a relation is a function if and only if it passes the HLT, horizontal line test. And just so we're understanding, this is, by the it, we're referring to the original. So it's a way that I can basically tell without having to graph the inverse relation. Okay. So let's do the flip side. What if this was your function? Well, not your function. What if this was what I gave you to begin with, and I said, hey, is the inverse of this a function? Yes, because this passes the horizontal line test. Okay, so it's possible that one or the other is true, right? Here's the second thing. It's possible that both are true, and we have a special name for those. Those are called one-to-one. One-to-one just means that passes both. Do you know what if I say VLT, will you know what I'm saying? VLT, vertical line test. What? What did you say? Oh, because you're hungry? And you're like, why is she talking about BLTs when we're talking about VLT, vertical line test, horizontal line test. Okay. You know, we have a lot of writing today, but we're almost done with the writing part. Would you please open up your book a second? Because I want us to look at some things. I'm just going to talk about if they have inverses that are functions. So, turn to page 123. Okay. And we're going to check these things. Some of them are functions, some of them are not. We're going to check their inverses, though, without graphing them. Okay? So number one, do you recognize this? What is the equation for that? 1 over x, look at you. Okay, this is a function. Would you check, does this have an inverse that is a function? Yes, this passes the horizontal line test. So this is a function and its inverse is a function. This would be a one-to-one function. Okay? All right, take a look at this. Is this a function? No, why not? I drew this first hour. Doesn't that fail the vertical? So this is just a relation, I would call this. Okay? But does this have an inverse that is a function? Yes, because it passes the horizontal line test. Okay. You know what that is? Good. This is an ellipse. Ellipses have a lot of uses, but they are not functions, are they? Does this have an inverse that's a function? So far, haven't we only found one of them that is one-to-one? Just that first one? Okay. How about this? Is this one-to-one? This is a function, but this does not have an inverse that's a function. Okay. All right. We could even go through the basic functions, starting with this one. This is a function, but this is not one-to-one. Hey, you know what we end up doing though? Because what undoes squaring something? I'm going to cover up this, and I'm going to cover up that. Does that look like the square root curve? Yes. So we actually can find an inverse for part of it, not the whole thing, for only when x is positive. Okay? So we do some things like that, which is why that affects the domain. All right, good. Couple more things. Put this away. So I talked about inverse relations. I talked about the points. We now know what we test to see if an inverse is a function. Now let's have a definition for inverse functions. And this is the last kind of formal definition I'll have you write. I don't often write formal definitions, but this one covers a lot of things that need to be talked about. So, if f is a 1-to-1 function, sorry about that, function, with domain D and range R, then its inverse function and the way we write that is f -1 is a function with domain R and range D. So the reason why I really wanted to make sure I wrote that is it does cover several things, and some of them I'm going to highlight. First of all, we've already talked about the one-to-one thing, okay? Domain D and range R, you might be wondering why I mentioned that. I'll get to that in a second. You need to understand this notation that if you see it, that does not mean f to the -1 power. Raising something to the -1 power actually means to take the reciprocal of it. You need to understand that when you see that -1 with an f, that refers to the, you could say, f inverse. Okay, f inverse. The other thing I want to point out to you is this. What happened to the domain and range of f? The domain of the function becomes the range. Okay, now, doesn't this just go back to what we talked about first? X's and Y's are switched. Domain has to do with X, right? Range has to do with Y. So now if I reverse them, I hope it makes sense to you that the domain now has to become the range of that. All right, so one other statement I want you to write is this. What this means is if this is x and this is y, f inverse of b equals a, then on the function, I'll write arrows so we know that it works both ways, then f of a would equal b. This is just the reversing of the points, but I'm writing it in function notation rather than as ordered pairs. Okay, I know there's a lot in there. Do you have any questions so far? So we started inverses with, I had you list the steps and then you undid them, okay? Many of you are going to be able to do that with a lot of the functions, but we should talk about the process for finding an inverse, because not all functions you can do that way. First of all, I'm going to talk about one of the most famous inverse functions. Okay, really the most famous? No, but for this class. Did you know that these were inverse functions? I want you to just think about it. Doesn't this have a horizontal asymptote? And it goes through the point 0, 1. Tell me about ln x. Vertical asymptote and goes through 1, 0. And by the way, sometimes I like to even do this. This is the line y equals x. When you graph a function in its inverse, they're flipped over, they're reflected. It's like a geometry thing over that line. Pretty nifty. Okay, you wouldn't have been able to, I don't know that you would have known that those were inverses. Okay. Another thing you should know is the function 1 over x is itself inverse. If I said, what's the inverse of 1 over x? It's 1 over x. Which kind of hopefully makes sense. Alright, but how do you do it? I'm going to give you one, and then I'm going to talk about how, if they're not the special ones, how you find the inverse. Okay, so let's find the inverse of x cubed plus 4 algebraically. In your book, it does give a list of steps, by the way. Like it says this is what you do, but I'll show you. And it hopefully will make sense. To find the inverse algebraically, what we do, basically, is we reverse the x and y. Makes sense. But there's no y here. How can I write a y here? What did you learn about what is f of x really? It's y. So the first thing I tell students is, hey, we're going to rewrite this. We're not changing it. We're going to rewrite it so it's in x, y notation. Okay, I have not done anything to the problem. Yeah. Then we are going to reverse x and y. Here's what that looks like. Instead of y equals x cubed plus 4, that would look like x equals y cubed plus 4. Finally, if I want to put it back in function notation, I have to solve for y. Now, this sounds easy, but sometimes it's not. It's easy now in this one. There's one on the homework where it's not so easy, but I want you to try it. How would you solve for y on this one? Let's get y alone. Subtract 4. Then take the cubed root, and you got to do both sides, the whole thing. So the cubed root of x minus 4 equals y. And then finally, let's write it as an inverse. That means that f inverse of x equals the cubed root of x minus 4.